Okay, so we are at the higher order derivatives, implicit differentiation, derivatives tables. That whole unit we're finishing up and we're wrapping this up. This is a review sheet that I asked you to print or copy down. And I'm going to do number 1 and number 3 and 5A with you. The rest will be homework. Your next assignment from us will be another worksheet that will serve as a homework, but it will count more than the homeworks have in the past. At this point, you know that your average for fourth quarter will be 50% on homework and 50% as tests. The next assignment will be worth more than a homework, so it will be underneath a test and more points. Okay, so let's get started. The first question is asking you to find dy dx. And so if you see x and y's mixed together, you know this is implicit differentiation. That means that when you take the derivative, you have to remember, did I take the derivative of y, that I need to finish off by saying dy dx. And you might still feel comfortable taking the derivative of every variable and finishing by saying the derivative of that variable with respect to the independent, but we've discussed why dx is not necessary, but would not be wrong if you show it. So here we go. When I look at this, I see that this is a polynomial, and I just give myself a preview, and I look at each term. I go, okay, that one's pretty basic, and y squared is basic, but what's not basic is this xy. That's going to require the product rule when I want to take the derivative of that. So when I do that, my personal opinion is I like to treat this with the negative outside, and then I will do the product rule on xy as positive x times positive y, and I'm going to worry about that negative at the end. You could take that negative and place it inside there. I just get worried that you're going to make a sign error, so I prefer to keep that negative outside. So now let's get started. When I take the derivative of x squared, that becomes 2x, and you could technically say dx, but I'm not going to. Then I'm going to do this minus here, and I do a parentheses, and now I'm going to do the product rule. I'm not going to worry about that negative right there. And when I do the product rule, at this point we should start practicing saying the product rule out loud so we don't have to make that key anymore. It's the derivative of the first. Well, the derivative of the first is just 1 dx times the second, which is just y, plus the derivative of the second. Well, the derivative of the second is 1 dy dx times the first, which is just x. And that's my product rule. I'm done with that, but I'm not done with the entire expression, so I continue. Plus, the derivative of y squared is 2y, but this also requires a dy dx because I just took the derivative of y, equals the derivative of 9 is 0. So now I'm here, and when I see 2 dy dx's, I know I'm going to have to GCF the dy dx out and isolate the dy dx. But before I can do any of that, I got to deal with this parentheses. This negative 1, now I'm going to distribute that in. And so when I do that, I get 2x minus 1y minus dy dx times x plus 2y dy dx equals 0. So now I have these two dy dx's. These two dy dx's, they're going to stay on this side. So the term that doesn't have dy dx, well, they're going to move over to the other side. So I'm going to minus this 2x and add 1y over to the other side. Minus 2x, add 1y. And when I do that, I'm left with a negative, be careful, a negative dy dx times x plus 2y dy dx is equal to negative 2x plus 1y. And now that I have all my dy dx's on one side and everything else on the other, I'm ready to GCF the dy dx out, and I'm left with a negative x plus 2y equals negative 2x plus 2y. And now you want to get dy dx alone, So you just divide by that binomial, and I get negative x plus 2y on the bottom here. So I get dy dx is equal to negative 2x. Oops, I accidentally wrote a 2 here when it should have been a 1. So negative 2x plus 1y over negative x plus 2y. Now, a great question that I got in one of my extra help Google Meets was one of my students wanted to know if I could just cross out these negatives, and you can't, because you would have to GCF the negative out. If you wanted to do that, and I don't want you to, this is my final answer, but if you wanted to take out that negative, it would be a negative parentheses 2x minus y over negative x minus 2y, and that's the only time you could cross this out. So these expressions are equivalent, and this is just fine to leave your answer as so. So that was the first part, 1a, that was dy dx. The next part of the question says to find the slope of the tangent line. Well, if you see here, finding the slope of the tangent line, you know the slope of the tangent line is the derivative. And we have the derivative, that was already done. And they want us to know at the point 0, 3. Well, in the past, we've only required ourselves to know the x value. But here, we need to know both x and y in order to evaluate this slope. So all this one requires is for you to now take this derivative that you found and apply the x and the y that's given to you. Negative 2 times 0 plus 1 times 3 over negative parentheses, wherever I see that x, I'm putting a 0, plus 2 times y is 3. And so when I get that, this just cancels out, and that turns into 0, and this is just 3 in the numerator and 6 in the denominator, because negative times 0 is just 0. And then my answer is 1/2 for the slope. Now part C says, write the equation of the tangent line. Well, you know that if you want to write the equation of the line of tangent to the curve, every time you see write the equation of a line, you know you need to use point slope formula. So you need to know your point, which is given to you. You're given 0, 3. And you just did in part B, your slope is 1/2. So now you're ready to write the equation. It's just y minus y1 is equal to m times x minus x1. So it just becomes y minus 3 is equal to 1/2 x minus 0. Now you can leave your answer like this, but for AP purposes and just in general, they usually just get the y by itself. 1/2 x plus 3. And that would be your final answer. And then last piece is find the equation of that normal line. We remember that from the last unit, that the normal line's perpendicular to the tangent line. That's why it's always nice to have this to refer to. Because yes, that's the equation of the tangent line. And if I want the normal line, I'm just going to go back to this step, and all I'm going to do is take this slope of 1/2, and to be perpendicular, it's the opposite reciprocal. So it's going to stay y minus 3 is equal to, well, the opposite reciprocal of 1/2 is negative 2 over 1, which is just negative 2 times x minus 0. Again, you can leave your answer like this, or you would get negative 2x, you add that 3 over, and this would be the equation of the normal line. So you're going to practice that in your homework in number 2. Okay, so now number 3. In number 3, they're asking us about higher order derivatives. And when we're trying to do higher order derivatives, I just know that I can't skip. I need to go from the first to the second to the third. So they're asking me to go to the first derivative, second derivative, and find the third derivative. So the most important piece that I think that most of you guys are struggling with is remembering to rewrite the original in a proper form. So you know you can't deal with radicals. So I'm rewriting that as 4 over x minus 2 over x to the 1/2. But you also can't take the derivative of a variable in the denominator, so I need to bring this x up, and I need to bring this term up. And anytime you want to bring a variable up, you just have to apply a negative exponent. So f of x is equivalent to 4x to the negative 1 minus 2x to the negative 1/2. So if you see, my notation hasn't even started to change. It's still f of x, 4x to the negative 1 minus 2x to the negative 1/2. So now you want to go ahead and take the derivative of this. So when I do that, it's f prime of x is equal to negative 4x to the negative 2. This, be careful of those signs. 1/2 times 2 is just 1, and a negative times a negative becomes a positive 1x, and you're bringing this down by a whole, so then this is negative 3/2. And so this is my first derivative. Now you could rewrite it as negative 4 over positive x squared plus 1 over the square root of x cubed. However, I need to find the second derivative, so I need this back in this form. So your second derivative, you take the derivative again. That negative 2 comes in front, and when you're going in front, that becomes positive 8x to the negative 3. You're dropping that down by 1. This comes in front, and I get minus 3/2 x. Again, I'm dropping it by a whole, so it becomes negative 5/2. And that is okay to leave your answer like that. Again, if that was my final stop, then I would just write, okay, it's over 8 over x cubed minus the 3 and the 2 stays as 3/2, and this joins the 2. The x goes on the bottom, it's a square root of x to the 5th in the denominator. But because we want to get to the third derivative, now I got to go back to this form. Okay, and when you take the derivative of that, that becomes negative 24x to the negative 4 minus, this gets multiplied in front. And guys, multiplying with fractions is really important. Negative times a negative, it's going to be a positive. 5/2 times 3/2, you're multiplying numerator with numerator, denominator with denominator. So I get 15 over 4x, and you're dropping this down by a whole. That becomes negative 7/2. And your final answer, your third derivative, without negative exponents, would be negative 24 over x to the 4th plus 15 over 4, and that x down here, square root to the 7th power. And I'm going to stop this video and start a new one for the last part.